Good morning, students. Thank you very much, students, for clicking on my video. I'm your Nagini ma'am, chemistry mentor. In today's section, I'm going to discuss about the coagulation topic, students. Here in this section, I'm giving the best tricks to understand coagulation, coagulation value, coagulation power, Hardy's cultural. These are the topics from surface chemistry, students. Here I'm giving the best tricks. You can easily understand this topic, students. After completed my topic, students, you will feel very easy, and next one, you can easily answer the questions based on this topic, students. Okay, Nama. Okay, now see, students, first of all, what is the coagulation? What is coagulation? First of all, what is coagulation, students? Precipitation of colloidal salt particles is called coagulation. So first of all, what is coagulation? Coagulation. What is coagulation, students? Coagulation is nothing but precipitation of colloidal salt particles. Precipitation of colloidal salt particles. Colloidal salt particles is called coagulation. Are you clear? Colloidal salt particles is called coagulation. That means the colloidal particles are converted into precipitate, students. Are you clear? So colloids are converted into precipitate. Okay, so that is nothing but coagulation. Are you clear? So colloids convert into precipitate. Okay, now suppose I am taking here negatively charged colloid, students. Suppose I am taking the negatively charged colloid. This negative, negative, negative. This is a negatively charged colloid. Negatively charged colloid. Okay, so negatively charged colloid, to the negatively charged colloid, when we are adding electrolyte, students, suppose I'm adding the electrolyte, students. Suppose AB electrolyte I'm adding. Okay, in electrolyte, one is cation, another one is anion, students. So A plus B minus. This is the negatively charged colloid. Here these are all the colloidal salt particles are move away from each other. They are maintaining the distance, students, because they are all having the same charge. In between the same charged particles, repulsions are taking place. So that's why here the colloidal salt particles are move away from each other. And here whenever electrolyte is added to the negatively charged colloidal salt, what will happen, students? These negatively charged colloidal particles attract the oppositely charged particles, students, from the electrolyte. So that means these negatively charged colloidal particles attract the positively charged particles from the electrolytes. Are you clear? So this negatively charged particle of the colloid, and this is the electrolyte. From the electrolyte, positively charged particles both are attracting. So what will happen, students? Minus plus will get, what will happen, Nana? Neutralize. So both will get neutralized, students. Both are neutralized. Minus plus, it is neutralized, students. So whenever neutralization takes place, what will happen, students? All particles are come closer to each other because they don't have any charge. So that's why here what will happen? Neutralize means the molecules are formed like this. Molecules, are you understanding, students? Molecules are formed. So these molecules are calling as, this is the precipitate, students. That means here all molecules are come closer to each other because they don't have any charge. So that's why here precipitate is formed. Are you clear? So the colloid is converted into precipitate, students. How it is converted? By the addition of electrolyte. Are you clear this one? So here I am taking the negatively charged colloid, and when we are adding electrolyte, students, these colloidal particles attract the oppositely charged ion from the electrolyte, gets neutralized, students. Okay, now then produces precipitate. Are you clear? Precipitate, that means here neutralized, that means they don't have any charge. Whenever molecules are having no charge, then the molecules are come closer to each other and they can form the precipitate, students. Are you clear? So this is the coagulation. Okay, now I'm going to discuss the coagulation value. Now see students, what is the coagulation value or flocculation value? Coagulation value or flocculation value. What is coagulation value or flocculation value? Now see students, coagulation value or flocculation value both are same. What is the definition? The minimum number of millimoles of electrolyte is required to coagulate 1 liter of the colloidal solution. Students, what is the definition students? The minimum number of the number of minimum number of millimoles of electrolyte is required to coagulate 1 liter of the buffer solution, 1 liter of the colloidal solution. Students, oh, sorry, not buffer, 1 liter of the colloidal solution, 1 liter of the colloidal solution. Are you clear? So what is the definition students? The minimum number of millimoles of electrolyte is required to coagulate 1 liter of the colloidal solution. Here we understood, by the addition of electrolyte the colloidal particles convert into precipitate. So how much amount of electrolyte? That means minimum number of millimoles of electrolyte. Okay, now how many millimoles of electrolyte is required to coagulate 1 liter of the colloidal solution you are taking? Are you clear this one? So here 1 liter of the colloidal solution you are taking. So that is nothing but coagulation value. So that means how many millimoles of electrolyte is required? Electrolyte is required to coagulate how much students? 1 liter. So this is the, for example, this is a colloidal solution. For example, I am taking positively charged colloid. Okay, positively charged colloid. This is I am taking just now 1 liter. Okay, now so 1 liter of the colloidal solution to convert into precipitate. Okay, here electrolyte A plus B minus I am taking. So how much amount of electrolyte? That means here it is in millimoles. Okay, na millimoles. How many millimoles of electrolyte is required to coagulate? Means to convert the colloid into precipitate. Are you clear this one? Into precipitate. 1 liter of the colloidal solution to convert into precipitate. How many millimoles of electrolyte is required? That is nothing but coagulation value. Clear this students? Coagulation value. Now we are discussing problem students based on this coagulation value. Now see Nana, problem I am going to see students, here we are going to discuss the problem coagulation value problem. So for the coagulation of 500 ml of arsenious sulfide salt, 2 ml of 1 molar NaCl is required. What is the coagulation value of NaCl is asking students. NaCl is asking coagulation value, how to find it. So first of all, here molarity given 1 molar NaCl is required. So first you find the take formula, Nana, molarity formula. So what is the solution students? Molarity is equal to, we know that formula, the number of moles of solute present in the 1 liter of the solution, correct? So we can write this formula, weight by gram molecular weight into 1000 by volume, correct? 1000 by volume, this is the formula molarity. Now here weight by gram molecular weight is nothing but number of moles, so that's why molarity is equal to N. Here by V I am writing here, this is N, this is number of moles students, this is weight by gram molecular weight is equal to number of moles by volume into 1000. Are you clear? So this formula I am going to use students to calculate the minimum number of millimoles. N value I am going to calculate here. So from this formula, N is equal to how much students? N is equal to M into V by 1000. Are you clear? M into V by 1000 students, correct now? Right. So m into v by 1000. Now what you will get, students? N is equal to, m is the molarity. Molarity how much given? 1. And volume how much given, students? 2 ml given. So 1 by 2 into 1 into 2 by 1000, students. Are you clear? So this value we can write it as 2 into 1000 by 1000, we can write it as 10 power minus 3. This is the number of moles we calculated. But according to the coagulation value, what is the coagulation value, students? Definition: the minimum number of millimoles of electrolyte is required. Millimoles asking, millimoles. Okay, now. So that is the definition. Millimoles of electrolyte is required. We have but in the question they given moles. Okay, now. So that's why we calculated first number of moles. After that we have to convert into millimoles. This number of moles we have to convert into millimoles. So one, this is the mole, students, units. So but we know that 1 mole is equal to how many millimoles, students? 10 power 3 millimoles. Okay, now see, students, 1 mole is equal to 1 mole is equal to 10 to the power of 3 millimoles. Okay, 10 power 3 millimoles. So this value here substitute in place of mole. Then what you will get, students? Then this value is converted into millimoles. So n is equal to 2 into 10 power minus 3. 1 mole is equal to 10 power 3 millimoles. So that's why 10 power 3 millimoles. Are you clear, students? In the case of mole, what we are writing? 10 power 3 millimoles. Now this one will get cancelled. So n value is equal to 2 millimoles. Understanding, Nana? So 2 millimoles. So that means 2 millimoles of NaCl is required. NaCl is required. Okay. Here we calculated number of moles of NaCl because we know that NaCl molarity volume given. So that's why we calculated number of millimoles. So millimoles of, how many millimoles we got? 2 millimoles we got. So that means 2 millimoles of NaCl is required to coagulate 500 ml of arsenious sulfide salt. Are you clear? But according to the definition, to coagulate 1 liter, to coagulate 1 liter of the colloidal salt, 1 liter. Are you clear? So 1 liter of the colloidal salt, according to the definition, 1 liter of the colloidal salt. Okay, to coagulate, how many millimoles of electrolyte is required? We have to find it, students. Now see, Nana, here 2 millimoles we got. So that's why here what we are writing. See here, 2 millimoles of electrolyte, 2 millimoles of NaCl is required to coagulate. Okay, now how to coagulate? According to the question, how many ml of arsenious sulfide given, students? 500 ml. Are you clear? 500 ml of arsenious sulfide. Okay, arsenious sulfide. Understood, Amma? So 2 millimoles of NaCl is required to coagulate 500 ml of arsenious sulfide. But we have, what we have to find coagulation value means for 1 liter of arsenious sulfide. To coagulate 1 liter of the arsenious sulfide, how many millimoles of NaCl is required? We have to find it. Are you clear? That is the coagulation value. Okay, now according to the definition, for 1 liter of the colloidal salt, how many millimoles of NaCl is required? How many millimoles of electrolyte is required? That is the question. Okay, now here 2 millimoles of NaCl is required for the coagulation of 500 ml of arsenious sulfate. Now I am taking 1 liter. 1 liter is nothing but 1000 ml. 1000 ml of arsenious sulfite for the coagulation. How many millimoles of NaCl is required? That is the question, students. Okay, Nama? Now calculate, students, cross multiplication. This one, this into this equal to this into this one. Okay, right. Now cross multiplication, students. X into 500, x into 500 is equal to 2 into 1000. Are you clear? So x is equal to 2 into 1000 by 500. Understood, Amma? 500 in 1000 two times, then x is equal to 4 we got. That means how many millimoles of electrolyte is required for the coagulation of 1 liter of arsenious sulfide, students? 4 millimoles of NaCl is required. So finally 4 millimoles of, therefore 4 millimoles of NaCl is required. Okay, is required to coagulate. NaCl is required to coagulate 1 liter of the colloidal solution, 1 liter of the colloidal salt. Okay, so this is what is the colloidal salt? Arsenious, okay, sulfide salt. Okay ma, so this is nothing but coagulation value, students. Like this you have to find it. Okay now, so what is the coagulation value, how to find it? So 500 ml of arsenious sulfide, this is a colloid, this is electrolyte, this much is required for the coagulation of 500 ml. Asking coagulation value is nothing but for the coagulation of 1 liter of arsenious sulfide, we have to find for 1 liter. Here in the question they given 500 ml. Okay, for 500 ml, first of all, how many millimoles of NaCl is required, we have to find it. After that, okay, now for the coagulation of 1000 ml of colloid, how many millimoles of NaCl is required, we can find it. So that's why here molarity given. Just here molarity formula, right? Here weight by gram molecular weight is nothing but number of moles by V into 1000. We are going to find number of moles. So but 1 mole is equal to what, Nana? Millimoles. How many millimoles? 10 power 3 millimoles. So here substitute, you will get millimoles. That means 2 millimoles of NaCl is required for the coagulation of 500 ml of arsenious sulfide. But according to the definition, coagulation value for 1000 ml of arsenious sulfide, how many millimoles of NaCl is required? So finally we got 4 millimoles of NaCl is required for the coagulation of 1 liter of the colloidal salt. Are you clear, students? Okay. See students, next second question. For the coagulation of 100 ml of arsenious sulfate salt, 5 ml of 1 molar NaCl is required. What is the flocculation value of NaCl is asking. Flocculation value or coagulation value, both are same. Okay Nama. So here also, so here 5 ml volume given, NaCl electrolyte 1 molar given. So first you have to find number of moles, students. After that number of moles we have to convert into millimoles, students. Number of moles we should convert into millimoles. That many millimoles of electrolyte is required for the coagulation of 100 ml of arsenious sulfate. For the coagulation of 1 liter of arsenious sulfate, how many millimoles of NaCl is required? That is the coagulation value. Understanding, students, according to the definition, what is the definition? The minimum number of millimoles of electrolyte is required for the coagulation of 1 liter of the colloidal solution. Clear? So 1 liter of the colloidal salt to convert into precipitate, how many millimoles of NaCl is required? That is the coagulation value. Okay Nama. So from this one, here what given, from this one 5 ml of 1 molar NaCl, we are going to calculate first molarity. Molarity is equal to formula N by V into 1000, students. Okay, now N is equal to molarity into volume. Okay, molarity into volume by 1000. So N is equal to molarity, how much given, students? 1 given, into volume, how much given? 5 given, by 1000. This value we can write it as 5 into 10 power minus 3 moles, correct? So but we know that 1 mole is equal to how many millimoles, students? 10 power 3 millimoles. Okay Nama, 10 power 3 millimoles. Okay, so use this formula, students. Now here N value how much? N is equal to you will get 5 into 10 power minus 3. Mole is nothing but 10 power 3 millimoles. Okay, millimoles. This one will get cancelled. So N is equal to 5 millimoles. Understanding, students? That means 5 millimoles of NaCl is required for the coagulation of 100 ml of arsenious sulfate. Are you clear? So this one, how much we got in millimoles? 5 millimoles. So 5 millimoles of 5 millimoles of NaCl is required for the coagulation of 100 ml of arsenious, okay, 100 ml of arsenious sulfate. Understanding? So but question is, for 1 liter of arsenious sulfate, how many millimoles of NaCl is required? So here I am taking 1000 ml. 1 liter is nothing but 1000 ml of arsenious sulfate. For the coagulation, how many millimoles of NaCl is required? So a cross multiplication, x into 1000, x into 100 is equal to, okay, x into 100, okay, is equal to 5 into 1000. Are you clear, students? 5 into 1000, 5 into 1000, Okay, then you will get x is equal to 5 into 1000 by 100. These two zeros will get cancelled. 50 we got answer. So that means 50 millimoles of NaCl. 50, therefore 50 millimoles of NaCl is required for the coagulation of how many? For the coagulation of 1000 ml of arsenious sulfate. Arsenious sulfate, students. Clear this one? So this is nothing but coagulation value, students. I discussed the two problems. Okay, now two problems I discussed. Nana. See, students, coagulation power. So what is the coagulation power, students? It is a reciprocal of coagulation value, students. What is the definition? It is the reciprocal of coagulation value. Are you clear, students? It is the reciprocal of the coagulation value, students. So that means coagulation value is less, coagulating power is more. Are you clear, students? Coagulation power is more. That means both are inversely proportional, reciprocal. So that's why coagulation value is less. If the coagulation value coagulation value is less, then coagulation power is more. Are you clear, students? Coagulation power more. Okay, if it is more, coagulation power is less. Are you clear, students? That is nothing but coagulation power. Understanding? So it is a reciprocal of the coagulation value. So coagulation value is less, coagulating power is more. Coagulation value is more, coagulation power is less. Understanding, students? So here this is the coagulation power. Now see, students. See, students, example, NaCl coagulation value is 0.72, aluminum chloride coagulation value is 0.092. So which is having the more coagulating power is asking. We know that coagulation value, coagulating power both are inversely proportional, reciprocal according to the definition. So which is having the more value? Coagulation value is more. Here a question is which is having the more coagulating power. That means coagulation value should be less. That is having the more coagulating power. So here if you observe NaCl and aluminum chloride, here coagulation value which is small, students, this is 0.72, this is 0.092, this is small. Are you clear? So this value is small. Okay, coagulation value is small. Okay, so that's why small means coagulating power is more. Are you clear? So coagulating power is more. Understanding, students? Coagulating power is more. So answer is aluminum chloride coagulating power is more. Understood, Amma? Coagulating power is more. So this is the answer, students. So that means here aluminum chloride, it is readily forms the precipitate. No, readily forms the precipitate. That means it readily converts the collide into precipitate, students. That is the coagulating power. So whenever aluminum chloride is added to the collide, it is immediately, that means it is convert the collide into precipitate, students. That is the coagulating power. Understanding, students? So that is the coagulation power, students. Clear this one? Okay, Nama. See here, students. Hardy-Sculls rule. What is Hardy-Sculls rule, students? More is the charge, more is the coagulating power. So valency is more, charge is more, coagulating power also more, students. That is the Hardy-Sculls rule. What is Hardy-Sculls rule, students? More is the charge, more is the coagulation power. Okay, now definition is more is the charge, more is the coagulation, more is the coagulation power. Okay, more is the coagulation power. So this is the definition. More is the charge, more is the coagulating power. Okay, Namma? More is the charge, more is the coagulation power. Now you can understand, students. See here, I'm taking the positively charged ions, coagulating power of cations for the coagulation of negative salt. coagulating power of cations I am taking first. Coagulating power of coagulating power of which one we are taking, students? Coagulating power of cation. For coagulation of negative sol. Okay, negative sol. Now see students, here I am taking the cations. What are the cations I am taking? Aluminum, calcium, sodium. Okay, aluminum, calcium, sodium. Aluminum plus 3, calcium plus 2, Na plus. These are all the cations. Now see students, here what I told you, more is the charge, more is the coagulating power. Here charge plus 3 is there, charge is more. So that's why this cation is, it is having the more coagulating power, so it is greater than this is the order, students. Okay, now this coagulating power of cations, this is the order. These cations are readily forms the coagulation, students. So that means in these three cations, which is readily forms which is having the more coagulating power? Aluminum, because it is having the more charge. So that's why it can readily forms the that means it can readily convert the collide into precipitate, students. Are you clear? Aluminum plus it. So that's why here cations for the coagulation of negative salt to the coagulation, that means negative salt should convert into precipitate. That means which charged ions we should add, students? Positively charged ions, cations we should add. Yes or not? Are you clear, students? This is a negative. When we negative salt, for the negative salt, when we are adding positively charged ions, cations, then both should be neutralized and then forms the precipitate. Are you clear, students? This is cations. To the negative salt we are adding this cations. Okay, this negative salt, to this salt we are adding cations. Okay, the cations we are adding, then both will be neutralized and forms the precipitate. Understanding, students? And next here, which is having the more charge, so that's why its coagulation power is more, because according to the Hardy-Schulze rule, more is the charge, more is the coagulating power. Here charge is more, so that's why it is readily forms the precipitate. Understanding, students? Now see here, one more I am taking, coagulating power of coagulating power of anions. Here I am taking cation. Now I am taking the coagulating power of anions for the coagulation of which sol? Positive sol. Are you clear? Positive sol. So that means to the positive sol, which ions we should add to get the precipitate? Anions we should add, negatively charged particles. So what are the examples, students? Negatively charged particles we can take that Fe CN6 4 minus, PO4 3 minus, SO4 2 minus, Cl minus. Now see students, these examples here, these are all the anions. Here which is having the more charge, this is having the more charge. Madam, this is negative charges, now it is less, the more value is there means less. No, just you see students valency. Only you see number, students. You don't consider the charge. Are you following? So 4 means here charge is more, so that's why it can readily forms the coagulation, that means readily forms the precipitate. So that's why this is the order, students. Are you clear then? So this is the Hardy-Schulze rule. More is the charge, more is the coagulating power. Understanding, student? Understanding, amma? So that's why in the above example here, aluminum chloride, if I take here NaCl and aluminum chloride, which is the more coagulating power I asked. So here we can say that here NaCl aluminum chloride. In NaCl aluminum chloride, students, here see NaCl aluminum chloride. Na plus aluminum, which charge, students? Plus 3. Are you clear? Na plus Cl minus dissociates. This is Cl minus. Okay, Al plus 3, 3 Cl minus. Now see students, here Cl minus both are having the same charge. Okay, now this Na plus Al plus 3, which is having the more charge, aluminum is having the more charge, so that's its coagulating power is more when compared to sodium, NaCl. So that's why here our answer is aluminum chloride is having the more coagulating power according to the Hardy-Schulze rule. Are you clear, students? Hardy-Schulze rule. So that means which is having the more valency, that is having the more coagulating power. Understanding, Nana? So according to Hardy-Sculls rule, this question you can answer easily. Okay, Nama. So these are the topics. So these are the best tricks, students. You can easily. I hope you understood this video, students. Here we discussed coagulation, coagulation power, Hardy-Sculls rule. These are the topics I discussed, Nana, in this section. Okay, I hope you like this video, students. If you like this video, please like, share, comment, and subscribe my channel, students. Thank you very much.